Good morning and welcome back to the 2214, and hopefully this will be the last video about the recursion. Okay, and you can see on the screen we have the quicksort algorithm presented in the Zaibook, and we're especially interested in the function which is called partition. Okay, you can see partition has three input parameters. Okay, one is the integer array numbers that actually contain the array we want to sort. And then there are two more input parameters. One is called I, the other is called k. This is actually represent the segment of the array that we try to partition. What does that mean? So basically, we have a long array, okay, but in this specific partition function, we are going to work on the segment starting from index I and ending with index k. And what we're going to do is we're going to choose one value in this range from the I to the k item in this array, and we choose one as the pivot. And then we are going to divide from I to k, from item I to item k, into two segments. So the pivot will be in the middle. Well, it will be somewhere in the middle. When I say in the middle, I don't mean like right in the middle. And then we will have a smaller or equal, and we will have a larger or equal. In other words, we're going to put this guy right at its position, and we're going to separate the whole component into two parts. One is smaller than or equal to the pivot, the other is larger than or equal to the pivot. Okay, this is what we're going to do. And there will be one return value. The return value is an integer which basically provides the index of where this guy is. So in other words, where is this cutting point we cut that we have the smaller half and the larger than or equal to half, smaller than equal to half and the larger than or equal to half, where it is. Okay, this is what this partition value going to do. Okay, so we're going to give three examples, and we will be able to figure out how did they do it. Okay, so the first example will be a perfect case. Okay, so following the previous example, we use 68 as the pivot value, and we're going to have 74, 72, 70, 60. Oh, I'm sorry, my bad. Okay, in the first one, we're going to have the perfect case. I'm sorry, my very bad. Okay, so you can see we have an array containing 9 elements. And the reason we say this is a perfect case is this the pivot value we're going to choose. And for whatever reason, the left half, they're all smaller than the pivot value we choose. I guess we're lucky. And on the right half, we have all the values larger than the pivot value. Okay, so this is the perfect case for your partition. Okay, and of course, this guy has the index of 0. This guy has the index of 8. So this is the I. Let me see the number, and this is the k. Okay. So let's see. Initially, the first time you're calling the function, I'm going to partition the whole array, and the first index is 0, the last index is 8 because I have 9 elements altogether. Okay, so let's see what happened. So these are definition, and the midpoint is I plus k minus I divided by 2. I is 0, k is 8. 8 divided by 0 divided by 2, which will give you 4. So pivot will be number 4, which is exactly this guy. So we're lucky we choose 68 as the pivot. Okay. Now let's see what happened. And of course, you initialize the low value is I and the high value is K. So basically the low is here and the high is here. Now what do? We enter a nested loop. Well, not down. Of course, the down is false, so you enter here anyway. Well, number low smaller than the pivot, you are moving further. You are moving forward. Okay, if it's smaller than the pivot. Okay, 66 is smaller than the pivot. 68, you're moving forward. 65 is moving forward, moving forward, moving forward. Okay, so here is the trick we're introducing. Do you remember we're saying, hey, using pivot, we are dividing the array into two parts. Okay, one part contains all the values smaller than or equal to the pivot, and the other part contains all the values larger than or equal to the pivot. Okay, you will feel pretty strange. Usually, what do? We have a pivot, right? So everything smaller than or equal to, we go this way, and everything larger than, go to the other way. In other words, we don't allow the equal to part appear in both sides. But in this specific algorithm, we allow that to happen. Later, we're going to see an example, okay? So here we have a perfect example which all the numbers in the before the pivot will move forward. Why? Because all of them smaller than the pivot. So the value of low will keep increasing until what? Until here. Why? When low equals to 4, we are accessing A4, and A4 equals to pivot, and now we stop. Okay, so here you can see, because here we use the symbol smaller than. Okay, we don't use smaller than or equal to. So this value low will not cross the pivot in the first round. It will never cross the pivot. Why? Because it equals to the pivot, so it will not go beyond the pivot. Okay, same thing here. Then we try to reduce the high as pivot smaller than the number from the other side. We're going down. So this guy is going down, reduce high to this guy, to this guy, to this guy. And finally, we keep reducing high, and we reduce high to a value that is no longer larger than the pivot. Again, we hit the pivot. Okay, we hit the pivot. It's no longer larger than the pivot. So here, h stop again. H equals to what? Equals to 4 as well. Okay. Now we look at this. If low is larger than or equal to high, in other words, the low end already crossed the high pointer, then down equals to true. We switch the flag, said, hey, we're done with the partition. So we don't worry about else, right? Because it here is if low larger than or equal to high. In our specific example, low equals to high. And we go back to the while loop, and now it's down. And because down is true, so negative down is false, so this loop will finish. So we do nothing but return high. And what is the high value? The high value is 4. So we return this value, and we are telling the partition function that, whoever is calling the partition function that, hey, you know what? At position 4, we already separate the array into two parts. Before 4, they are everything smaller than or equal to the pivot value. Okay, and after the item 4, we have all the values that smaller than, larger than or equal to the pivot value. So we naturally cut them into two parts. And we know the pivot is already at its position. The next thing you need is just to sort the previous half and sort the second half. So you can see, if we zoom in and go down, so you can see, where is that? Quick sort. Okay. The first time you call quick sort is you're sorting what? You're sorting from 0 to the number's length minus 1. This is actually the index of the last item in your array. Okay, so you call this quicksort. This is the main function. And what is the quicksort do? The quicksort first get the partition. So it will partition the array into two parts. Okay, so the j in our specific example, the return value j is 4. It's 4. Okay, so in this way, it partitioned the array into two parts. Before 4 is smaller than the pivot, and the larger than 4 is larger than or equal to the pivot. I'm sorry, the component beforehand, before the pivot, is smaller than or equal to the pivot, and after that is larger than or equal to. So now we have j is the separation point, and then again you call the quicksort from I to j and from j plus 1 to k. So you already separated them and you call them again. Okay, now you sort the first half and you sort the second half. Okay, and so on and so forth. Okay, so this is the first example. Now let's look at the second example. Well, let's see. We see what, God forbid, it is not what you want. Okay, so again, we're saying, hey, 68 is here. And we have 67, 66, 79, 65. And here should be larger than 78, 54, 88, 99. Again, we still have 9 items. And we start here from the low, and here start from the high. This is I, this is K, and this is the pivot. Okay, so let's go through the loop. So what is the loop is doing? Firstly, you are looking for an item before the pivot that is larger than or equal to the pivot. Okay, so let's see. The low starts from 0, it's moving down, and we are looking for a number that is at least as large as 68. 67 is not, 66 is not, 79. So low equals to 2, low will stop here. Low will stop at 2. And then this loop already finished. And then what do? We go to the other side. We drop the high. Okay, we go down. 99 is larger than 68, 88 is larger than, and suddenly 54 is not. So high will stop here. I think this is 6. So the low is 2, high is 6. So in this half, we found a value that is larger than the pivot. And for this half, we found a value that is smaller than or equal to the pivot. So now both of these loops finish. And then let's look at this. If low larger than high, you quit. Do we have low larger than high? No, we don't. So we enter this part. What do we actually do? Here we are actually switching the two items in the array. Okay, this you should probably remember in your 12, 12, 13 course. When you try to switch two items, you cannot directly, use two line. You need a temporary variable. Okay. So what will happen? They will switch these two values. They will move 79 here, and they will move 54 here. After they move this, they will increase low and decrease high because they have done one thing. They are going to move the low to 3 and move the high to 5. So high will point to 78. Low will point to 65. They will keep going, and finally low and high will meet at the 4, and we're going to again we're going to quit because now we have this pivot separated them into halves, and one of them is smaller than or equal to the other one is larger than or equal to. Okay.